So let's take up our Chapter 9 quiz then. Now the first question says to find the intersection point of two lines. So to do that, it's easiest to look at it as parametric form, so just your x, y, and z equations, and you're going to equate them. So let's equate our two x's first. So here, our x equation for, let's call this line 1, is 1 plus 0t, or just 1. And that's going to equal our x equation for our second line, which is minus 5 plus 3t. And so we have 1 equals minus 5 plus 3t. That's actually quite simple. We just need to solve for t. So we will get 6 equals 3t, and therefore t equals 2. Now we're going to do the same thing with our y equations. So for line 1, our y equation is 1 plus t. So we have 1 plus t. And that's going to equal our y equation here, which is 4 minus t. It's a negative 1. So 4 minus t. All right, so rearranging here, we're going to get 2t equals, you know what? You shouldn't be using this equation. This question is sort of confusing because it's using t for both equations. Let's not do that. Yeah, let's change that. Let's change this into an s. So one of them should be s. Yeah, because then you think that it's the same thing, and it shouldn't be. You have two different equations for two lines. That's my mistake for putting the same scalar in there. All right, so let's redo this. So for y, we have 1 plus s, and that's going to equal here 4 minus t. There we go. Okay, so your y is here. You're looking at your parametric form. Why can't I click on laser? Here we go. So that's your parametric form is there. 1 plus 1s. So
oh, wait, actually, never mind.
Yeah. I mean, I could write them all in parametric, but I don't have that much space. So we got that. All right. So substituting, we already know what t is. T is 2. So we can write s equals 4 minus 2, and then bring this 1 over to the other side. So minus 1, and that gives us s equals to 1. So now that we know what s and t are, we can actually figure out what those x, y, and z coordinates are. And we want to do it for both line 1 and line 2 because they should equal. Well, certainly x and y should equal because we used those equations to solve for s and t. But z should equal as well. If z doesn't equal, then there actually is no intersect. Right? There would be skew lines there. So let's try x. So we'll do line 1. They're not really labeled, but let's say the first one is line 1. So we have x is 1 plus 0, so just 1. Y is 1 plus s. And since s is 1, that's 2. And z will be 2 plus s. And since s is 1, we get 3. Oh, that's a nice 1, 2, 3. Okay. Our second line, so let's test. They should be the same. It looks like the intersection point is 1, 2, 3, but that's only if we can get the same thing here. So our x is going to be minus 5 plus 3t. X is minus 5 plus 3t. Since t is 2, that's minus 5 plus 6, which is 1. Okay, so far so good. Our y coordinate is 4 minus t. And since t is 2, 4 minus 2 is 2. So far so good. Here's the real test though. Z. Minus 5 plus 4t. Minus 5 plus 4t. And since t is 2, that's minus 5 plus 8, which is, all right, 3. So our intersection point is 1, 2, 3. All right, so looking at the second question, we're trying to determine the intersection point of this line, which they give us in parametric form, and that plane. All right, so to do that, what we're going to do is take the equation of the plane, which is 5x, but we're going to substitute the values, or sorry, the parametric form of the equations in for x, y, and z. So instead of x, we will have 4 plus t. Okay. Plus 3y, but our y is 1 plus 2t. Plus 4z, but our z is 5 plus 3t. And then we have minus 20 equals 0. So if you rearrange that whole equation, so you want to make sure you expand and simplify, you guys are pretty good at doing that, I think. You should end up with 23t equals minus 23. And therefore t would be negative 1. All right, so that's telling us what t is, but we want to know the intersection point. Now, since we know what t is, we can figure out what that point is where the intersection actually occurs. So we're going to go to our parametric equations and use t as negative 1. So 4 plus t, where t is negative 1, that gives us 3. 1 plus 2t, 1 plus 2, and t is negative 1. So that's just 1 minus 2, which is negative 1. Finally, z is 5 plus 3t, where t is negative 1. So that's just 5 minus 3, so 2. So our intersection then is 3, negative 1, and 2. So this question says, determine the distance between that point and the plane. Okay, now I've told you what the distance formula is, but the distance formula requires you to have the plane in Cartesian form or in scalar form. This gives us the equation of a plane in vector form. All right, so the first thing we have to do then is go back and remember, how do you change a vector form equation to a scalar form equation? So to do that, what we need to realize is this is a direction vector on the plane, and that is a direction vector on the plane. Now in our scalar form, the coefficients a, b, and c are coefficients for normal to the plane. So we need to find a normal to the plane, or put another way, I need to find a vector perpendicular to both of those direction vectors, hence cross product. Yes, cross product is back. All right, so I'm going to do this up here. So our normal then is going to be the cross product of 2, 1, 3, and 4, 2, 0. All right, and you're going to get 0 minus 6 for our x, 12 minus 0 for y, and 4 minus 4 for z. So that gives us a normal of minus 6, 12, and 0. That's not a really fun normal to play with, so let's pull out a negative 6. And we're left with 1, minus 2, and 0. So that right there, right, the scalar multiple really doesn't affect it. It just affects the length of the vector. I really care more about a vector any vector that is perpendicular to both of these direction vectors. So the simplest vector is easiest to work with. And now that I know that, I can write the equation of the plane as ax, where a is 1, so that's just x, minus 2y, and then there's no z, plus d equals 0. Now I need to figure out what d is. And to do that, I need a point on the plane. And that's right here. That's a point on the plane. So our x would be 1, our y would be 2, and we need to solve for d. And so 1 minus 4 is negative, 3 equals negative d, or d just equals 3. So now I know the equation of our plane, x minus 2y plus 3 equals 0. That means I know what a, b, c, and d coefficients are, right? A is 1, b is negative 2, c is 0, and d is 3. And since I have this point, change color, I have this point that I'm trying to find the distance to the plane, that's our x naught, y naught, and z naught in our distance equation. So just as a reminder, our distance equation looks like this for a point to a plane. It's y naught plus cz naught plus d all over square root of a squared plus b squared plus c squared. So that's going to give us, we have 1 times 1, so 1, minus 2, and 0, so 0, and then d is 0, so another 0, and then d is 3, so 1 plus 3. All divided by, here we have the square root of, so 1 squared plus negative 2 squared plus 0 squared. Great. So that gives us 4 over the square root of 5. Right? So that's your distance to the plane, and if you want, you can say that is approximately 1.8 units, or 1.7.